Good day, everyone. How are you doing? This is me again, Mr. Navarro. Welcome to my YouTube channel. For today, we'll be talking about expressions with rational exponents and how to simplify them. So, what are rational exponents? Rational exponent is an expression written as a over x raised to a over b, where a and b are integers and b must be equals to 0. And of course, it's a power, so we have the base as x and the exponent as a over b. Since they can be a whole number, fractions, mixed fractions, and decimals, together with the negative images. So how do we simplify rational? How can we say that we already simplified rational exponents, right? So we must meet the following conditions. There's only two. One, no negative exponents. Okay, so basically the same rule that applies in laws of exponent, not a complex fraction. So since we are talking about rational exponents, we need to simplify things and make it into a simpler manner. Okay, so no complex fraction. So before you simplify expressions with rational exponents, you need to get familiar with the laws of exponents, right? So I already posted the video for that. You may recall on that and view the video in the link that was given to you. Okay, so let's proceed to simplifying rational expressions with rational exponent. First example, we have 32 raised to 1/5. So what could be the possible law that can be used here? It's exponential law, or the power of a power. But how can you apply that? First, it is you need to consider that 32 can be expressed as 2 to the power of 5, or if you multiply that one, you will have 2 times 2 times 2 times 2 times 2, or 2 times 2 4 times 2 8 times 2 16 and times 2 32, right? And then if you apply the exponential law, that becomes you multiply the exponents, you have 5 times 1/5, or 5 times 1, that's 5, and then all over 5, which simply lead us to 2 to the power of 1, right? 2 to the power of 1, but you may not write anymore. That is why our final answer is 2. I mean, you don't have to write the 1 anymore. Right? Next example is x raised to 1/2 times x to the power of 3/2. So here we have the same base, and then the operation is multiplication. Therefore, we're going to use the multiplicative law of exponents, or multiplying powers, right? So when we multiply powers, we add the exponent. Okay, so if you have noticed, the fractions here are similar. So when you add or subtract similar fractions, you only copy the denominator, do not combine them. Copy the common denominator, which is 2, and then you add the numerator. So 1 plus 3 over 2. Hence we have x to the power of 4 over 2. And if we simplify it, we'll have x squared, right? Next example, n raised to 4 n4 raised to 3/2. Power of a power rule. Okay, so you multiply the exponents. 4 times 3/2, so 4 times 3/2, so 4 times 3, that's 12 over 2, n raised to 12 over 2, and divided by 2, you'll have n6, right? If you have questions, you may type it in the chat box, comment box, I mean. Okay. Next example, number 4. So this part here, you can see that there is vinculum. Okay, so there is fraction form. So basically, you already have the clue that this type of expression uses the division rule or law of exponents, right? So when you divide powers, what you're going to do, you subtract the exponents, right? So 5, 6 minus 3, 6. So I already said earlier that when you subtract or add similar fractions, you only copy the denominator and you subtract the exponents. So 5 minus 3 to the power over 6, then 2 over 6, x to the power of 2 over 6. And then when you simplify it, you can still simplify to 6, so you can have 1/3 x to the power of 1/3. Therefore, the simplified form is x to the power of 1/3. Okay, next example, negative 8 to the power of negative 1/3. So here, it's if you're just going to look at it, it is impossible. But this one is possible. Why? Because if you can recall, negative 8 can be expressed as negative 2 cubed, right? Because negative 2 times negative 2 is 4, and then times negative 2, that's negative 8, right? And then you can use the power of a power law here, or power of a power rule. So what I mean is 3, you multiply the exponents, so 3 times negative 1/3, then you can have 3 times 1, so 3, and then copy the sign, 3 over 3. And still, there is still a negative sign inside the parentheses. Next is, you simplify, you can have negative 2 to the power of negative 1, right? Because 3 over 3 is 1. Still need to copy the negative sign. The next is, you apply the negative rule, or negative law, to make it positive, or if you don't want it to look like that, you can have it this way. Alright? So the negative sign is aligned to the pendulum. Alright? Next example. 3b 1/2 times b 4/3. Okay, so again, same base here, so you can combine the two b's. Then multiplication, so therefore we can use the multiplicative law of multiplying powers. Just copy the coefficient 3 here, then you add the exponent. Now, since the fractions here are dissimilar fractions, I've made a video of this, so you can visit that one. You're just going to look for the common denominator of 1/2 and 4/3. Okay, so the common denominator is 6. Then you're going to add 6 divided by 2 times 1, so 3. 6 divided by 3 times 4 is 12. So therefore, 2 I mean, so this is 8. This is 8. 8 here, right? Then 11. 6 divided by 3 is 2 times 4, 8. So 11 over 6. So then we make them equivalent fractions. So but here is the solution. Then 3b to the power of 11 over 6. Right? Next example, so the same fraction, so you're going to use the division, and then so here you can see a negative sign, so negative law will be applied. So next is simplify. Mine is to simplify the numbers, the coefficient, and then so that we can focus on the expressions itself. And then you use the division law, right? So negative 7 minus 4/3, right? I made a parenthesis so that the negative sign will be emphasized. And they have the similar similar fractions, so we used to look for the common denominator, which is 12, and then can have it 21 over 12 and then minus negative 21 over 12 minus 16 over 12, negative 21 minus 16 over 12, and then negative 37 over 12. Since they are both negative, you copy the sign and then you add 2. Therefore, your final answer is, since this is a negative exponent, make use of the negative law, make it positive. Alright. Okay, this in this example, this might take a while, but surely you'll get used to it. Okay, so the possible laws that you can use here are power of a power and division law. So what I used first is power of a power. I multiply the exponents in the numerator, so 3 and 3 times 3 halves and 2 times 3 halves. And then here, the 1/4, so negative 1 times 1/4 and then negative 2/3 times 1/4. Next is I simplified, so 9 halves, so 3 times 3 that's 9, 2 times 3 that's 6, so 9 halves and 6 halves. Negative 1 times 1/4 that's negative 1/4, and then negative 2/3 times 1/4 is negative 2. Well, you can simplify that one later on, but I only express it as that. Then you use the division law, so 9 halves minus the negative 1/4. Why do you still need to copy the negative? Because if you still remember the division law, there should be a negative outside, even if it's a negative sign here, even if the exponent here is negative sign, so still need to copy the sign here. And the same goes with the other one, right? So what will happen to the sign? It becomes positive, right? And then what happened here? It becomes 18 over 4. So I made them an equivalent fractions. Okay, so I look for the common denominator. Okay, so 18 over 4 plus 1/4, and then 36. The same goes here. 36 over 12 plus 2 over 12. Okay, next is I added them and then simplify them as this one. So 38 over 12 can still be simplified, that is why 19 over 6. Therefore, the final answer is x to the power of 19 over 4, y 19 over raised to the power of 19 over 6. Okay, so if you are having a hard time with this one, this part here, you can visit the video for you to understand this part. Number 10, last example. Okay, so here I'm using power of a power, division law, and negative law. So why is it power of a power? I multiply the exponents, okay, with 4. Okay, and then I got x squared because 1/2 of 4 is 2, and then negative 2 times 4 is negative 8. Negative 7 over 4 times 4 cancel on 4, so you'll have negative 7 y to the power of 4. Alright, since y here is 1, so 1 times 4 is just 4. And then you use the division law, so subtract the exponents. X to the power of 2 minus the negative 7, y is y raised to negative 8 minus 4. You simplify the exponents, so 2 plus 7, and then y to the power of negative 12. And then next is x to the power of 9. Then make the y be in the denominator. Alright. Next is therefore your final answer is x to the power of 9 over y 12. Okay, so if you want to practice answering this type of expression, simplifying rational exponents, you can have the following items. You can pause in this part and do the solving of the following problem. And you can also check your answer if it's correct. Here are my answers in the next slide. Thank you.